Welcome back everyone to more 6.2 calculations with tangents. There's not really a lot of new things in theory B, it's just they're going to give you multiple situations, scenarios, and they want you to now practice what happens if you, for example, have an adjacent side given and what happens if you have an opposite side given. So what happens if there is the hypotenuse is given? Take a look at that later on. You cannot use the hypotenuse when we're talking about tangents, but we luckily have a solution to that as well later on in this chapter. For example, here they want you to now calculate this side, not the angle, but the side here, which we can do. If we know in a right-sided triangle, we know one extra, you can say angle. We know this one is 90 degrees. We know that this one is 61 degrees. This is 70. We can now calculate BC. And here as well, if we have given that this one is 15, this one is 35. Just, you have a slightly different way to get there. Not really. You still have to use this formula. Only after filling it in, you have to use a different step. So here, we're going to use the tangent of angle A. Why of angle A? Because, well, I know angle A. So now using the tangent of angle B is going to be rather difficult, because then I have too much unknown variables in my calculation. So the tangent of angle A is equal to the opposite sides of A, which is BC, divided by the adjacent side, which is AC. So first write that down. Now fill in what you know. I know that the tangent angle A is given in this case, which is 61, equals BC divided by 17. Remember, tangent 61 is just a number. Punch it into your calculator and you just get a nice number. So this is not a variable anymore, right? BC is though, and BC is here in the numerator. But remember, if I have this form, if there was an x here, for example, I would get this times this. So here BC is equal to 17 times the tangent of 61. Punch it into your calculator, is approximately 30.7. Okay. But what if the opposite side is given inside of the adjacent side? Well, we can still work with that. Again, take the tangent of the angle that you know. Here we take the tangent of angle P for that matter, because we don't know Q. The tangent of angle P is equal to the opposite side QR divided by the adjacent side PR. If I now fill in what I know, I get tangent 50 equals 35 divided by PR. Here I don't know the denominator. Is that a problem? No, because it's still only one unknown variable and the rest are just numbers. Only now, because my variable is right here, remember, now I don't do tangent 50 times 35. I now get PR by dividing 35 by tangent 50. Punch it into your calculator and you find a number again. Okay, so in theory A we discussed how to calculate angles using the tangents. In theory B we'll discuss how to calculate sides, and we still use the same actual formula, only we use it a bit differently. Here we don't use any inverse tangents, right? We don't need to, because if I now fill in the tangent of that angle, this is just a number. So just calculate it and we're done with the tangents. Well, calculating if you're going to calculate an angle and we know the two sides, then we're going to use the inverse tangents. If I go back to previous slides, here we use the inverse tangents because I get tangent angle A equals 4.2 divided by 5.6. But I don't want tangent angle A, I want angle A. So use the inverse tangents on both sides. Here I don't have that problem because I get tangent and I already fill in the value of an angle, which makes me calculate the tangents and makes the tangent disappear. Okay, so you can say a small tip: inverse tangents you use when you're calculating angles. You don't use inverse tangents when you're calculating sides. Maybe a nice thing to remember it like that. And these are the new glossary words. Okay, practice this and of course ask questions during the lesson. Bye bye.